Hello and welcome to section 9.6. So in this section and next we're going to graph quadratic functions. So here we're going to start by looking at some properties and use those properties to help us figure out what the graph looks like. And then next section we're going to go into more details. So we're going to talk about what a basic graph looks like for a quadratic function, the symmetry of it, the axis of symmetry and the vertex. Those are like two very important things, and other details like the intercepts, xy intercepts, and what's the maximum or minimum, and also do some applications. Okay, so a quadratic function is a function of this form. So we have f of x equals ax squared plus bx plus c. Remember, the f of x gives you a formula that involves the variable x, and whenever you have inputs of x, if you plug in particular values of x, then that gives you the y values. So basically you plug in the x values and the output is the y value. So the function tells you what equation you need to follow, you need to use to plug in order to get your y values, right? And basically the procedure for graphing is, you can go back to the basics. Let's make a table of values, all right? So we can pick values of x and use the formula given by the function to figure out values of y. So we're going to look at this example. So we want to pick 0 is always good, and a couple of positive values, a couple of negative values. So this is not going to be the graph of a straight line because of that x squared. 5 points is really good to make a table for a function that's not a straight line because it has more detail. Alright, so let's plug in the values. Let's start with 0. So I have 0 squared minus 1 gives you 0 minus 1, which is negative 1. Alright, and I plugged in x is 0, I got y equals negative 1. So this generates a coordinate point that goes on my graph. Alright, let's get the others. We have 1 squared minus 1. 1 minus 1 is 0. So this gives me 1, 0. 2 squared minus 1. 4 minus 1 is 3. So 0.23. Negative 1 squared minus 1. This is positive 1 minus 1, which is 0. Negative 1, 0. And then negative 2 squared minus 1 is 0. 4 minus, is 3. 4 minus 1 is 3. So this gives me negative 2, 3. Alright, so let's plot the points. So I have 0, negative 1, 1, 0, 2, 3, negative 1, 0, negative 2, 3. Right? So we're going to join and draw the graph. Here you go. Right? This could be a little bit better. Let me just try this side again. 2, 3. There we go. Okay? Alright, so this is a typical graph of a parabola. So let's talk about some properties. So this point right here is very important. We got that point at 0, negative 1. This is called the vertex. Okay, so the vertex is that round point at the bottom where the graph of the function turns around. Alright, so it's kind of, you draw it, it's kind of the lowest point on the graph. This is a minimum in this function. Sometimes we'll get parabolas that turn upside down and the vertex is going to be at the top. But it's basically like either the smallest value of y, the lowest point, or the highest point. Right? We also notice that this is symmetric. right? So it's kind of like a mirror image. If you fold the piece of paper along the y-axis, the two sides are going to completely match. So you can look at this line right here that cuts the parabola into identical pieces that are mirror images of each other. This is called the axis of symmetry. Yeah? And we refer to it with an equation. It's like, oh, when x equals 0. So when x equals 0, that's where the line is. That's where the axis of symmetry is. All right. Other things we'll notice are the intercepts. So it has two x-intercepts. So this x-intercept right here is at x equals 1, y 0. And that one, x equals negative 1, y 0. So the x-intercepts happen when the y values are 0. And then the y-intercept is what's crossing the y-axis at 0, negative 1. The y-intercept happens when x equals 0. All right, so all these are called properties of the parabolas. Like, does it turn up? Where's the vertex? Where's the axis of symmetry? Where are the intercepts? And with that information, we can make a really good graph of a parabola. All right? Now, keep in mind, this is the basic shape of it. Right? So this is what all your graphs will look like. Sometimes thinner, sometimes more squashed up, sometimes moved in a different place, sometimes upside down. But it's not going to look like this. It's not going to look like this. This is kind of this basic U. So whenever you have a function that has ax squared plus bx plus c, a quadratic function, it has that basic parabola shape, right?